My name is Kyle Alexander. I teach 5th and 6th grade. I'm also helping work with the teachers with math instruction. So I'm in a little bit of everything right now in terms of math. Thank you for being here this morning. We're primarily going to focus on 3rd and 4th grade. So I know that some of you are in other grades, but thank you for coming, and we'll have some time for questions as we go as well. But in thinking about what to talk to you all about, I was looking at what are the big things that come up in 3rd and 4th grade, and what might feel different to you that that you'd like to talk about. And so in 3rd grade, we're looking at a couple things. Multiplication and division facts, which I'm sure are a big piece of what you're thinking about. Mental math, and we'll just briefly talk about that, and then getting into word modeling with some word problems, which I'm sure feels different than how you got instructed, because I know it does for me. But let's just jump in with the facts. Okay, so multiplication facts. 1st, 2nd, and 3rd, the kids are modeling their using manipulatives, they're touching things, they're building arrays. They're trying to come to an understanding of why 3 times 5 equals 15. They're doing a lot of hands-on showing what that looks like. In 3rd and 4th, the transition then becomes, how do we just know these? So building fluency with those facts. And so fluency in terms of speed, right, and accuracy. Both of those are part of fluency. So we spend a lot of time in the primary grades building understanding, and then we start making the transition into practicing facts, right? So that may look like flashcards, that may look like IXL, that may look like games, that may look like taking a deck of cards and flipping 2 over and multiplying them, right? So that by the end of 4th grade, 5th grade, they're coming in with knowledge of 1 through 12 multiplication facts. So the expectation is by 5th grade, they know those facts. So that we're not doing any teaching around facts in 5th grade, because they're using that in everything, basically. So you'll see coming home and practicing facts as part of their routine. And within class, they're going to be building arrays, working with disks, working with whatever things that we can make to create understanding for that. So, we're also looking at some mental math strategies. Most of you were not here in the first one, so I think we'll just do them together. So the kids may get something like 49 plus 26. And they're asked to come up with as many different strategies to solve that as possible. Okay? And so let's hear some. What do you do when you see this problem? What's your first thought? Marnie?
50 plus 25.
So 50 plus, you said 50 plus 25, and that becomes what?
Oh, really?
Hey, you gotta own it, just finish it out.
I'm gonna go with 75.
Fabulous. So, right, adding 1 here and subtracting 1 here. Did somebody do it a different way? I don't know your name, I'm sorry. Karina. How do you spell that?
C-A-R-I-N-A. I did it very old school. Sure, 9 plus 6, 15 carries 1,
Right. No, not at all. No need to apologize. We all have our own strategies. What else? Because there's more. What else did you do?
We do the 40, 20, split, 9, 6.
Can you tell me your name? With a K? So 40 and 20 is 60. 9 and 6 is 15. Come on, people. So 60 and 15 then? 75. Right. What else? Yeah?
You do the ones and the tens.
How so?
I mean, that's just what I see my daughter doing. You do the 6 and the 9, you add that together, and then you go to the 10s, and I guess you have to add the 1.
Okay, so
Down the ones where you have that here.
so we have 9 plus 6, and that's 15, but we know that that's too many ones, right? So this is 1 10 and 5 ones. So now we have 4 10s plus 2 10s plus 1 more 10. What was your name?
That's my intention.
What was your name again? Allison. 2 L's?
2 L's and a Y.
Ooh. Fancy. So then we have 6 10s. No, we have 7 10s. Sorry. Yikes. Let's try that again. Right? 7 10s, 5 1s. So the idea here is that we have all built strategies going along from K 1, 2, 3, and that we all get to come at these problems in whatever way makes sense to us, right? So where I may start by, and nobody actually did this either, but I may say, well, I guess Marnie did, that I need 1 more to get to 50, right? So I'm adding that 1. So that's 6, right? I'm breaking this into 25 and 1. So I can take that 1 and add it to the 49, and that way I have still 25 left. Because I would much rather work with numbers that are 0 numbers than work with 9. I don't know about you. But if I can make a 10, I'm going to make a 10 every time. And that works for me because that makes it easier. But that's not to say that there isn't a method that works for you too. And the idea here is that we're trying to allow kids the space to feel really comfortable with how they work with numbers. And so what works for you doesn't always work for me, but everybody gets to talk about it. And I may not have seen this. Like that's maybe not where I started, right? And so now I have another strategy because Karina offered it, right? Or I don't have another name. Jeff picked up on Marnie's method, right? Because she shared it. But giving space for talking about that, right? And allowing them to be experts, right? Because as soon as my name gets put on something, now it's mine. And that becomes my method, and we can talk about it like that. And we do, right? That kids get to have ownership of this. And the more they feel connected to it, the more apt they are to want to work with that. And so really allowing opportunities for talking about what's happening in their heads. Because so much is happening there, right? They get a problem, they see it, and they're starting, right? And I'm sure you're doing the same thing. You're immediately starting to, how do we put these together? What can we do? And having space to talk about those things and share them and be experts allows more of an investment in it. And that's what we want, right? We want them to leave here feeling comfortable with making and breaking numbers, with changing in between different representations of numbers, and with an enjoyment of it, right? That, like, this isn't just something you have to do for school, right? It's like something that becomes almost like a game. How do you think about it? How do you think about it? How do you think about it? Look, we just came up with 6 different ways to do this. What? It's one problem, right? And so, really getting that that buy-in from them of this is important. Yeah.
So when the teacher stands up and says, okay, here's how to do this, is she giving one of these examples, or is she making them go in and trying to figure it out themselves?
I think that, well, that depends. There's both happening. So sometimes I would throw this up and say, what do you got?
Okay.
Take 2 minutes, come up with as many different strategies as you can to get there. And then we'll share it out. And then Marnie becomes a teacher, and Karina becomes a teacher, and Allison becomes a teacher. And then I say, oh, well, I decided to make 50 because I knew that 1 and 9. So then I become another participant in the sharing, and I've now shared this strategy.
Because I think the problem, I'm sure many people that are here because their kids have a few tears that come down every once in a while with this thing, is that my daughter gets home and she's learned these different methods, which is awesome, but she can't figure out what it is she's supposed to do. So she's sort of more of a factual person, so you need to give her, here's your way to do this. And what I find frustrating as a mother is that I don't have anything to refer back to. I mean, I went and bought the textbook because she's not bringing home a textbook, she's bringing home a workbook.
Sure.
So when she gets to a problem, she says, I don't know how to do it. She can't go back to page 9 and say, okay, this is how you do it.
Yeah.
So therefore now we're adding in how we learned to do it 25, 30 years ago. And it may not be that way. So that's why I'm fearful that I'm screwing her up versus, the other side of it. Does that make sense?
Yeah, and I'm glad that you're here for that. That part of this is about looking at what is happening, right? And you can't screw her up. Well, here's the thing. Math is math, so ultimately we're going to get there. She's going to get to a place where she has a strategy, right? And maybe that looks like, what we've done, and that's okay. But it's totally okay. Having the book is helpful.
I just had to do it because math has always been the thing that I'm quite good at, so therefore I look at her and I'm like, I don't know, you can't do this.
Right.
So that's the problem.
In the textbooks, the instruction looks different. So it's not, my textbooks had the page of vocabulary, the page of 14 examples, and then about 95 practice problems. And the books don't look like that for this. The books teach through the thought bubbles. So there's a little kid with each thing, and then there's a thought bubble. And the idea there is that kids are learning from kids. And the thought talks about the modeling that's happening in the kid's head. This is what I did to solve that. And so that's where the instruction comes in. So if you've got the books to look at, then that's where you're looking for the actual instruction piece of it.
But they don't reference the book, do they? And they're not sitting in a textbook every day.
No. I mean, we open textbooks after teaching, right? So that comes after as more of a resource rather than an instruction.
Okay.
So the teaching is happening in small groups, in whole groups, in videos for some, and then if you need to, you can go back to that textbook as an example, and this is where we're at, say unit whatever. So that's available, but it's not our #1 resource in terms of instruction. Yeah.
So where I struggle with my daughter is that, I think we get mental math and we have the luxury of thinking about a problem, but then when it translates to time tests, she gets flustered and she can't do a thing. So how do they translate this into being able to do it fast without the luxury of sitting back and thinking about it?
So part of that is where the sprints come in and the fluency practice. So a couple times a week we're doing 1 minute or 2 minute timed just fluency practice to develop speed, because that's 3rd, 4th, 5th, 6th. K1, 2 looks a little bit different, but it's the same idea around, okay, we spend a lot of time touching things and manipulating them and moving them and proving that this is true. And now we need to actually just know that. That just needs to be part of our everyday knowledge. And so the transition piece is, okay, let's practice and play, and now let's try to do this quickly with no stakes, right? They're sprints, they're 2 minutes long, and they don't impact in any way necessarily, except to get a sense of where are we at? What do we need practice on? They're really good information for the kid and allows them, there's 2 of them, so you do a sprint A, that's your first go through, and then we talk about it, and then we do a second one. And the intention there is to try to improve on the first one. So if you got 10 in a minute on the first one, then you're shooting for 11 for the second one. You're trying to increase your own score. And what's happening with your neighbor has nothing to do with you, right? So that if your neighbor has 12 and you have 50, it doesn't matter, because it's all about where you are and your comfort with this. So that's the practice within class of speed and trying to get used to. Well, you know, the reality is that we just have to know these things too. And so we need to have automaticity with them. So that is built into the class as well. Now, facts, mental math, modeling. My guess is that modeling is probably the thing that is most foreign to you. It was to me. I didn't learn this way. And when I came into the program, I was kind of like, wow, this is going to take me a little while to get used to. And I love it. And here's why. Modeling allows for access to problems that kids might not have access to. It also gives them a place to start. Because word problems can be really panicky for some kids. And there's this sense of like, I'm not really sure where to start, I don't know what to do, I don't know what operation to use. And modeling becomes this jumping off point of like, okay, well, let's just look at what we got. And let's start there and see what's actually happening. I know some of you probably are visual people. You need to see things, or you see what's happening in pictures, right? And others of you hear it, and that works for you. Like if you can hear it, great. And some of you need to actually touch things, because that's what works for you. And modeling is just another tool to access word problems. That's all it is. It's another language, essentially, to the equations that we're doing. And so it just becomes this piece of how else can I represent my thinking? And how else can I show my understanding? Because sometimes kids don't know the operation, but they can solve the problem with the bar. And sometimes kids solve the problem with the equation immediately, and then they're like, I don't really know how to show this bar. And that becomes an opportunity to say, well, let's deepen your thinking. Let's work with this graphic, this tool, so that you have it when you hit a problem that you're not sure about how to solve. And really just pushing them to be out of their comfort zone a little bit, right? That if I can work with the equation, great, let's focus on the model. If I can work with the model, great, let's focus on the equation. But that both of them become a way to represent what they know. And so I wanted us to spend a little bit of time just going through a couple of these, because I think it's important that you have a feeling of what they feel. So if you can grab either a piece of paper or a whiteboard and a marker, something that feels right for you. If you grabbed a whiteboard, just so you know, inside the back of the whiteboard on the red side, there's a little piece of felt. That's your eraser. So you have that to use. I know, we're so smart. It's so great. Okay. This is a third grade problem. We'll do a couple third grade problems and a couple fourth grade problems just so you can see the transition between them. And there are a couple different models that we use depending on the situation. Do I have a volunteer that will read this for us? Come on, people. Do it. Go for it.
May had 600 paper flowers. She sold some of them and had 255 left. How many flowers did she sell?
Okay, so this is a part whole problem. We have the whole, we have one of the parts, and we're looking for the other part, which means that we need to start with one bar to show our whole. So I'm going to, that's my bar, right? That's my total. What's the total worth? How much? Great. So I'm going to label that 600. Now, it tells me she sold some and she had some. So how many parts am I going to break this bar into? Great. And are they the same size? No. So I want to try to be within reason, estimate about how much. I want those bars to make sense in terms of like the distribution. So she sold some, we don't know how many, and she had 250 left. Well, that's a little bit less than half. So that's, I'm going to mark off and say that's what she sold. I'm sorry.
But no, they would have to know that that's less than half to do that.
Mm-hmm. And that becomes the conversation of what makes sense in terms of how much are we using. Did she use most of it? Did she use about half of it? And having that conversation that, here.
But they don't need to know, it just helps them visually to make it a little more.
Right. So I would say if we were doing this with kids, and I can't do it. Oh, I don't have. So I would take my marker and I would go across the bar and say, tell me when to stop. So if they stop here, my question would be, do you think that is a reasonable estimate of how much she has left? No. Okay, so let's try it again. Tell me when to stop. And that just becomes an opportunity to talk about reasonableness, which is what ultimately we want them to understand, right? Does this make sense? Is this reasonable? So I show that she has 255 left. What am I looking for? How many she sold. So that's here. Now I know that this is a whole part problem, right? And we've talked about this in kindergarten, we've talked about it in first grade, we've talked about it in second grade, right? All this is whole part. If I know the whole and I know one of the parts, I can find the other part, right? How do I do that? What equation could I write to solve this problem? Anyone want to venture out and say it? Right, so once I've got the model, then I can come over here and I can do the subtraction. And maybe I do it mentally, maybe I write it out like this, but I'm solving that problem. I've connected this picture, this drawing, with this equation. And then we solve it. So has anybody solved it? Can anyone put that in a sentence for me? Right, because that's what we do, right? We draw the model, we write an equation, we put our answer in a sentence, and we do that because we want to make sure that we're answering the question that's written. Sometimes we answer the wrong question because we're assuming, or because we're pulling numbers randomly. Right, we're going back to what are we actually solving for?
So if this is a test question, and I don't know what directions we have got it, but if the kid goes in and does that and nothing else.
Does this?
Yeah, just put 600, 255.
Okay.
And doesn't do the model
the expectation is that they're doing all 3 parts. So they're getting credit. If I had a kid who doesn't do the model but does the work, then they get credit for the work and they don't get credit for the model. Right? So both of them are expected because we want them to be able to show understanding in several different ways.
Okay, and then the related question is, let's just say that was your math problem right
Yeah.
there. And your instructions say, solve this equation using 3 different approaches. And one kid does Marnie, one does Carrie, one does Christine's, and then the other kid goes the other way. Is that okay?
Yeah.
That shows you the range of understanding
Yeah.
and the different approaches, and you don't care what those 3 approaches.
Yeah. I mean, I had it. The like attachment to the right way is a lot less.
Yeah, that's what I'm trying to
Right? Like that I may have one way, but that doesn't make your way any less feasible and reasonable. Yeah.
Well, I guess the way I'm thinking is, so if they do it the way on the right, they understand the problem, they get the right answer, why then is the model also important?
Because you do want to get more different. They're still understanding pieces of how much whole versus a half. Only because I you get it in your mind because you know. They're still getting the comprehension of this is the whole, this is part of the whole, and what's left of the rest of that little piece that I started. That's where fractions, when we got into fractions, all this all of a sudden came together. So.
Go ahead, Tracy.
So, using this approach and making them flush it out, is that what's going to help them transition from Singapore math to any other kind of math?
Yeah, because what happens is now I have a tool that allows me to say, okay, what's happening in this problem? Where do I start? It becomes this like internal dialogue of how do I take a problem that I'm not really sure how to solve and start somewhere. And some of our kids still are doing models, right? Outside of here. That's a tool that they've internalized. It doesn't mean that it's something that they have to use, but it works for them. And it gives them this access point that they may not have had. So you did.
I heard that people like higher level engineering and creativity into this field. And I think this way, but I'm not there. But after moving to like traditional math writing, like much later in high school, like this fell in place. So I think even my daughter is like, what should I do is I really understand this, but she has access to this. I'm hoping that she internalizes this area that I think, because it helps to get the whole concept of what is math for, right?
Yeah.
This is more of a 5th grade question, but when I'm helping my son through this one, with a lot of these problems, my way of approaching would be more an algebra approach. I'm assuming we would avoid because they're not familiar with that.
For right now.
Correct?
Yes. Yeah, but that's the thing, and I love that you said that, is that they're doing algebra problems in 4th, 5th, 6th grade that they wouldn't have had access to. Some of the 6th grade problems, I am blown away by what they end up being able to do because of this, that they wouldn't necessarily have access to if they didn't have this. And so that for me, and I know you're not there yet, but that is huge in seeing that.
So we know it's 3:45, but now I'm a 3rd grader, and now I'm like, how do I do 5 through 10? How do I do all that?
Yeah, so they've had instruction around that, and what that'll look like is, well, this 600, that's 600s, but right now I don't have enough ones, so I'm gonna go to the 10s, but actually I don't have any 10s either, so I need to somehow create 10s and 1s out of the 600s that I have. So instead of using 600, I'm gonna use 500. And that's gonna give me 10 10s. That extra 100 is 10 10s. So now I have 10 10s. I have 10 10s, but I still need 1s. So I'm gonna get rid of one of those 10s, leave 9 of them, and give me 10 1s. So now I have 10 1s, 9 10s, and 500s, and that still gets me to 600. Right? So now I have all that, now I can do that subtraction. And I'm ready to go.
Okay, so we solved the problem.
Right.
Are you guys teaching checking your work?
Yeah, so that's where, again, this comes in. Okay, so if I now know my 2 parts, how do I solve for my whole? Well, I just add to get back. And I can check. It's a built-in check system because they're all connected to each
And are
other.
they doing that as part of their, I solved the problem, now do I check my work?
That's a great question. I don't know. I don't know in 3rd and 4th grade. I could ask. My hope is yes. That becomes just kind of a built-in, try it and check it out.
Right.
But I don't know. I'd have to find out.
Because I've been pushing checking your work, but she
Should.
says to me, well, I'm taking a test, I'm not checking my work. And I get that, but right now, she's in 4th grade, this is all still brand new, so I
Right.
think checking your work is,
Yeah.
she would have to do that.
Yeah. I mean, the conversation with my kids is, especially on the test, is always go back and use whatever inverse operations you can use to check. Now, there it looks a little bit different because we're dealing with decimals and repeating decimals and that kind of thing, but to the best of your ability, check and see what's reasonable. Yeah.
Can you say that one more time? Because that is actually backwards in the way I would approach it. I was noticing this with my son. Like we would start with ones and move it to the hundreds. And he's starting with the hundreds and saying, you're all wrong.
You want me to walk through it again?
Just the reasoning, like you say, you start in the hundreds place.
Yep.
And then you work.
Okay. Yeah.
Can I try and understand it and explain?
Yeah.
So,
That just made my day.
so you know now, they do the 6 and make it a 5, so now you have 100 tens or 100 ones. But they know that they have 10 tens to work, right?
So you,
then you add that to the tens column, but now you don't have any ones, so now you know you need to make ones, and so you cut out the 10 and bring over the 9.
how many tens do I have?
2 tens. Oh, wait,
When you got rid of the 100, how many tens did you have?
10.
10 tens.
Yeah.
And then what did you need to do for the ones?
Then I needed to take one of the tens away and make it now 9. Okay?
And how many ones do I have now?
Now I have 9. No, 9.
Yeah.
See, I mean, that's obvious because you have 2 zeros in the lower digits.
Yeah.
So, I mean, you wouldn't necessarily know that if it was saying 6, 4, 5, and underneath you had larger numbers of the tens and ones. Do you see my point? Like you don't have to borrow until you start from ones column necessarily.
Oh, I understand. Yeah, that's why we started in the hundreds because we didn't have any
Yeah.
to
But
work
if
with.
you were, it wasn't zeros in this place.
I'd
it's
start with
right to
ones.
left,
Yeah.
right?
Oh,
Okay.
yeah,
Working backwards.
it's the same, our daughters are learning right to left, I've never seen left to right, so is it okay to do right to left?
Yeah, you just need to have enough kind of across the board. And we start with the ones. We jump to the hundreds because we didn't have enough in the tens or the ones. Yeah. Well, ladies and gents,
Is there a reason that now, I don't know, like.
why do we use this language?
Than the way we learn, like you said, going from right to left, I don't know.
Yeah, I'm happy to, you look like you want to address that.
I feel like it's actually the exact same way we learned it, but just putting language to it.
Yep.
So we crossed them out and put 5, moved it over to 1, but you didn't really understand why it was happening, and now you're saying, okay, you're taking one of the 100s and it's now 1010s. We used to just move it over the 1. And I truthfully, I don't really understand why we did that, but we just did it. This is doing the exact same thing, and just having an understanding of one. Right?
Yes. And I feel like as a person, as a math teacher, I have learned way more about math as teaching it than I ever did as a student. Because I was just going through the motions of it and I had no idea what was actually happening. Now, right? Yes! Right, it is. It's this lovely language. Yes! Right, so it becomes this opportunity to really understand what you're doing. You want to try another one?
Yes.
Yeah, well, you don't have a chair. So we're going to try another one. I need a different volunteer. Somebody read it.
134 girls and 119 boys took part in the art competition. How many more girls than boys participated?
Right. So this one, I don't have part whole. I am comparing. So that means I need 2 bars to compare. I've got a bar for the girls, and I just put a G to signify that's my girls bar. And I'm going to show the bar, and it's 134. Now, I need a bar for the boys. Is that going to be longer or shorter? Shorter. Right. So why don't you tell me when you think I should stop? Stop. Great. And I'm going to mark that as the 119. And it asks me how many more girls than boys. So I'm looking for the space between, right? I'm looking here. That's what my question is. But ultimately, if you think about it, it still kind of comes back to part whole, right? The whole being girls, the boys are one part, and the missing piece is the other part. So now I'm still in this relationship, which means what kind of problem is this? And the equation, what operation are we using? Subtraction. Okay, so it's still connected back to what we just did. But the bar looks different because we're comparing. They're not all coming from the same place. Right? And that's all that's different. So we would solve this. Anyone want to tell me the equation for this? Right? And so here, coming back to the question earlier, well, I look at the ones. I've got 4 ones, and I'm trying to take 9 ones away, so I need to go to the tens. And I need to take one of those tens and give 10 ones to the ones. So now I have 14 ones to work with. If I have 14 ones, then I can subtract the 9 ones and solve from there. Okay, so, excuse me. These 2 have been 3rd grade. Let's jump to
15.
I love it. You should come to my class. I love it. Okay, so jump with me to 4th grade. Reader, anyone?
A farmer had 1,045 ducks. He had 294 more chickens than ducks. How many chickens and ducks does she have altogether?
Okay.
Oh, is it a farm?
Threw that in. So, part whole or comparison? Okay, so we're comparing ducks and chickens. We know that there's one of those categories has more than the other. So we need to have 2 bars, 1 for each. I'm going to start with the ducks because that's what they give me first. Okay? So I have 1,025 ducks. He has, I'm sorry, I screwed that up. Sorry about that. I got 1 and 1. She has 295 more chickens than ducks. So the bar for the chickens, is that longer or shorter? Longer. Right. Excuse me. How many chickens and ducks does she have altogether? Now, there's 2 things that we're going to need to do first before we can actually solve that. 1, we need to show how much more those chickens are, and we know that that's 295. We're looking to solve all together. We need all of it. What information do I need to know first? Right, we need the chickens before we can find all of them. So the first thing that I have to do is solve that question, then I can find all together. But now I've got all these pieces and they're all here, right? It's clear that this bar right here is the same as this space right here. Well, that I can just put together, right? So I add my 1,025 and the 295 first. That's going to give me my chickens. Once I know the chickens, what is the next step to find the total? Add it to the ducks, right? And so we've created this picture of what's actually happening here, and we're saying, what's the relationship? We're seeing how these two things are related to each other. That clearly I have more chickens than I have ducks, and I now know that because I'm showing that visually.
So don't you have another bar model that shows the addition of the ducks and chickens?
That is
We double that?
Nope, it's this bracket tells me we're doing all together. We keep the models as simple as we can. We don't want to make this more confusing than it needs to be, right? So keep it as simple as you can. So 2 bars or 1 bar, whatever we can do to make that represent.
And do you work on the verb? I mean, I think for me, the hardest part of a problem, a reading problem, is using the words all together has more than. I mean, do you guys work on those, kind of pulling those words out and saying, what does this word mean? If you see more, it means addition. If you see this, it means subtraction. Multiplication.
Okay. Yes and no. So one of the really nice pieces about Singapore math is that they use words interchangeably. So that we aren't just picking out this word means this word means this, because we want to build understanding enough that we can take any situation and solve it. And so there's actually less of a push to say like more means subtraction or altogether means addition and just have problems, but we spend a lot of time breaking these down.
The words,
Yeah, so in 3rd grade, which is really where bar modeling starts to come in, they do a little bit of it in 2nd grade, but then 3rd grade is like a big push. They're breaking these problems down bit by bit and saying, okay, now let's show this, let's take this piece, what does this mean, how does this impact this now? And it becomes a running dialogue of questioning, what is happening here? And so there's a lot of teaching that's happening to breaking those problems down. Let's take a look. Oh, you want to solve it? Okay, well, we need to find the chicken. Sorry, I didn't realize there was an attachment to this. We need to find the chickens first. So what is the total chicken? 13.
Right.
Wow. No, I wrote it just, yeah. Okay, and then to find the total? Now we're going to move on. Sure.
3rd grade, and I'm at 4th grade, and 4th. We started multiplication. So multiplication is 60. I use the bar model.
That's next. I promise I'm getting there. So Sean has 1,135 US stamps. He has 3 times as many foreign stamps. So how many stamps does he have altogether? So again, we're comparing, right? We're comparing US stamps to foreign stamps. But now I've got 3 times as many. So I have a base in my US stamps, and then the foreign stamps are 3 times that. So I'm going to start with the US stamps and make 1 bar. That's going to represent the 1,135. But the foreign stamps are 3 times that, so I need 3 of those. So now my unit becomes the US stamps. Okay? Each of those then are 1,135. If I want to find all together, how many units do I have? 4. So then the equation becomes what? Yeah, the 1,300 or 1,135 times 4. I don't actually have to solve the foreign stamps first, unless I'm asked that. But since all of these are the same unit, I can just say 1, 2, 3, 4 of the same units, and then do that multiplication.
How did they do the multiplication?
Okay, so we're looking again at thinking in terms of place value. So I have 4 ones times 5 ones, that's 20 ones, right? But I can't have 20
Say
ones.
that again, 4 ones.
4 ones times 5 ones, that's 20 ones. Well, I can't have 20 ones in the ones place. So I'm going to leave that and change it into 2 tens. So the 2 tens are now in the tens place. I have 1, excuse me, I have 4 ones times 3 tens, right? So 4 times 3 tens. You know what? I'm going to start that over. Because this, we're not actually thinking about it in terms of ones. It's just a unit. So I'm sorry about that. So we have 4 times 5 ones. 5 ones, 4 groups of 5 ones is 20 ones. So now I have 2 tens because the 20 ones becomes 2 tens. So I have 3 tens times 4. That's 120 tens plus 2 more tens, right? That's 140 or 14 tens, right? So the 14 tens is 4 tens and 100. So that 100 goes to the next place. 4 times 100 is 400 plus 1 more extra 100 is 500. And then 4 times 1,000 is 4,000. Sorry, I needed to start that over. Now, the reality is that if we're doing these problems, if we're doing a bunch of them over and over again, I might not use that language every time. That I might say 4 times 5 is 20, and the 2 then goes into the tens column. And 4 times 3 is 12, plus 2 more is 14. But that the kids have heard that. They know that that's what's happening. The instruction and the conversation has happened around why the 2 is going above the tens column and the 1 is going above the hundreds column. We've had those conversations, so there's a connection to it. Versus just, no, I put the 1 up top and then I add that, and it becomes this thing that they've already seen over and over again, just like the multiplication facts, right? If they've seen it happen over and over, now we're just saying 3 times 5 is 15. What you got?
Okay, so using the language that you're using, right? You've got 3 tens and you've got 2 tens. So why wouldn't the kid's brain go to, well, I have 5 tens, which would be wrong?
3 tens, because we had to multiply the 4. So 4 times the 3 tens first.
Right.
That's what we have to do. That's our 12 tens. And then we have 2 more extra tens. So 14 tens.
Okay, I'm trying to put myself in the role of the kids. Like,
Totally.
2 tens, 3 tens, 5 tens.
Right. And so there is kind of that process of that those extras come at the end. Right? That we're finding the total first. Yes. The second problem is attached to this. So we have 4,540 stamps. And what happens if Sean now takes those and separates them equally into 5 groups? So now there's a second bar because now we're doing something different. We're putting those all together. So now I have this whole group of stamps that Sean has. And we said that was 4,540. How many parts are we breaking it into? 5. So are they the same size?
Yeah.
Right, so I'm going to do my best to equally break this into 5 groups. So now we're looking at a division model. Right? This was our multiplication model, units, showing the same units. Now this is our division model. We're taking our whole, we're breaking it into equal parts. I'm looking to see how much are in each packet, so then that's my question. Right? I've got 1 of those packets. Do I need to label all of them? No, because they're all the same. right? So I'm just finding 1, and then I would do that division. 908. Yeah, we're going to talk about division. Just give me a second. We'll get there. I promise. You're going to love me. Oh, so it is 908 in this case. For the sake of time, I think we'll move on to division because we're just almost up. Okay. Yeah. Yeah. So there's two ways that instruction is happening around double digit, typically. One is multiplication as we've seen it, right? 5 times 2, that's our 25. We have 2 10s. 5 times 9, 45 plus 2 more is 47. Now, when we get to the second row, the language that we're using actually is super zero. Yeah, the kids love it. And so if you've heard it, great, that's good, because we keep using that. But can somebody tell me why we're putting a 0 into that place, aside from it's a placeholder? Say that again?
Multiplying by the 10.
Right, so now we're multiplying by the 10s. This 2 isn't a 2. It's not 2 1s, it's 2 10s. So now we're starting in the 10s column. And that's why we put in that super 0. So the kids will call this super 0. And use that language at home too, right? But they know, and the instruction is happening, that we put that there because it's now the 10s place that we're working from. You also may see 95 times 20 and 95 times 5, and then adding them. So you may see these as 2 separate problems, partial products. So the 95 times 20 we would find first, and that's 1900. And then the 95 times 5, and that's 475. And they may write those like this, and like this. I don't. I know a couple different boxes, but I'm not sure which one.
It was basically 95 and 0, and then you draw a four-square box, put it this way, multiply this way, and then add them.
Do you use the...
I was blown, my 4th grader taught that to me, and I was at the park trying to preface by amount of math.
With the diagonals?
Yeah.
Okay.
Yeah.
That's actually, and I forget now.
No, not like that. It was just the rounded numbers in each of the 4 quadrants and then multiply them.
Okay.
And then add it together again.
So the partial products,
Yeah.
like that. So, like this,
Yeah.
90 times 20, 1800, 90 times 5, like that. Is that how she did it? There's a couple different ways you can do
Yeah,
this.
no, actually it was the 95 and 20 and 95 and 5 inside the quadrants, and then she added them together. It's essentially that, what you just did.
Yeah.
It was just visually different.
Got it.
So the one that is see where you created 2,
Uh-huh.
Then you go to the 10s column, and do you teach them to just cross out the 2 because they're not going to need it anymore?
Yeah.
So it uses the wrong carry number.
Yeah, some kids find a strategy of erasing those. Some kids cross them off. Some kids will cross off this once they're done and go to the 2. That's telling them that they can move on. We introduce a lot of that. They kind of grab onto whatever works for them. We feel okay with multiplication? Okay. So in 4th grade, long division looks like this. It looks exactly like you have talked about. The difference is, and this goes back to what Marnie was saying earlier, the language that's attached to it. So if you'll bear with me, I want to show you what instruction looks like around long division. It starts with the discs. In front of you at the table are the discs if you feel the need to touch them, just to see what the kids are using. but we draw them a lot too. Okay, so they're different denominations, and I would start by modeling this 145. I've got 100, 4 10s, 5 1s, and I'm dividing that into 6 equal groups. So the conversation starts with, well, if I look to the hundreds and I want to break them into 6 groups, I can't do that. I only have one. Can I borrow this for a second? I only have one of these. So I can't, as it is, break it into 6 equal groups. So I need to do what? What can I do? I can make 10. So I can get rid of the 100, and I can make how many 10s? 10 10s. Oh, 1. So I would make 10 10s. Sorry. Now, I have how many 10s to work with now? I have 14 10s. So if I want to break those 14 10s into 6 equal groups, how many 10s are going to go into each group? 2. 2 of the 10s are going to go into each group. How many of those 10s have we now used? 12. I've used 12 10s. How many are left? I have 2 10s left, so all of these are gone. But I also have those 5 1s. The 2 10s and the 5 1s then become 25 1s. Right? So now I have 25 1s in order to do that division. So 25 1s divided into 6 equal groups gives me how many 1s in each group? 4. How many 1s have I used? I've used 24. How much do I have left? I have 1. And we report that in 4th grade as remainder 1. Right? And so the modeling starts. That's where we start. We start with those discs, we're modeling. We're breaking up, we're making we're breaking hundreds into 10s, 10s into 1s. Then we transition into doing both. We're doing the modeling at the same time as we're doing this kind of standard algorithm that we're used to. And then we transition into just doing this, where we say, okay, I'm breaking 1,525 into 5 equal groups. I have 1,500s, and I'm breaking those into 5 groups. 1,500s broken into 5 groups gives me how many hundreds in each group, right? That's my 3. How many hundreds have I used? Well, I've used all 1,500s. And now I have 2 10s to work with. But I have 2 10s, and I'm breaking that into 5 groups. That's not going to work. I don't have any 10s to use. Now I have 25 1s. 25 1s broken into 5 equal groups gives me 5 1s in each group. I've used all of my 1s. I don't have anything left. I've got no remainder. So that's what division looks like and sounds like as a process for us. And we are trying to use that language to help them see what's happening. Yes?
Okay, so my dog's reaction to all this is, oh my God, I'm so stupid, I can't do this, I'm so stupid. How do you deal with this frustration?
Yeah, so 1, no, you're not stupid. And 2, where can we start? Keep coming back to what do you know? What do you know? What do you know? And sharing your own thoughts. Like, this is where I would start. This is what I'm thinking. Could you tell me what you've heard around this? Like, it becomes an opportunity to have a dialogue about what do you actually know and where can you start. I think that for me is the big piece. Like, where can you start? What do you know? Where can you start? And then work off of that. And that becomes, then you're not stupid, right? You're fabulous and you have these strategies. Let's just use them.
I got a little life lesson from Ms. Lewis this past week, and it was sort of the concept of your daughter can actually do this in class. It's when she's home with you and you're sitting here doing cooking while she's doing her homework. She knows that she can look at you and ask this question. So what she asked us to do was to move Ella into a place where she was by herself so that she couldn't turn around and ask me a question. it is amazing how much of the homework she actually gets done without asking me anything and then coming in and having maybe 2 problems wrong versus 8 that she initially was saying, I can't do these, I can't do these. So while you think sometimes maybe you're adding lots of their lives and business, I was actually taking away. So it was great. I mean, first I thought that's never going to work. Totally worked.
Thank you for sharing.
So
She had no problem going into her room to do it.
she went into her room, she did all the things, and she came out and she said, I don't get these 2. But initially, she would sit there and like every other problem, this doesn't make sense, this doesn't make sense. But being by herself, she had to focus by herself. So.
We are at past time. Thank you so much for participating.